Давайте я запишу. Я потом отправлю в Telegram. Кто какое-то место не понял, вы можете заново посмотреть видео. Я начал записывать видео, значит, so equation solving, derivatives, integrals. This what you should know from mathematics, and from vector calculus also you should know the vector calculus. Vector calculus. For example, divergence, rotor, gradient. Can you take divergence, rotor, gradient of vectors? The nabla operator. Nabla operator, for example, is I unit vector d over dx plus j unit vector d over dy plus k unit vector d over dz. This is the gradient operator, or in other words, it's nabla operator. This letter is Greek letter nabla. Do you know this operator? This is learned in vector calculus. So divergence is nabla. For example, gradient is nabla nabla f, for example, or this is dot product. Or rotor is vector product, cross product, nabla nabla f, etc. Okay, if you don't know this one, so when we use derivatives, rotors, gradients, I'll explain this topic in more details. This will be in energy. When we deal with energy, conservative, non-conservative forces, I'll explain what is gradient. Okay, this is what you need to know from mathematics. Now, you are still 3 people. I should check what about others. Okay, then I think nobody will join, so we can continue with 3 people. If somebody will join later, I'll send them our video recording. Okay, let's start. Then our main topic, physics. So let me explain first about the structure of this online course. So we are learning physics 1. Physics 1 consists of 2 parts: mechanics, classical mechanics, and thermodynamics. Classical mechanics and thermodynamics. So this is 10 lessons, 10 online lessons, 2 hours each lesson. So then 5 lessons for mechanics and 5 lessons for thermodynamics. In total, 20 hours, 10 hours for mechanics and 10 hours for thermodynamics. So in mechanics, we deal with kinematics, dynamics. Later, I will send all this my notes, so you can see my notes and learn them, and also you can watch the video. Kinematics, dynamics, statics, energy, work and energy. and then rotation, rotational dynamics, rigid body, then mechanics of the liquids. This is also mechanics. Sometimes it's called fluid mechanics. We deal with fluids. This is mechanics part, and then what is thermodynamics part? Thermodynamics part is the ideal gas theory. Here we learn the equation of ideal gas, equation of the state of the ideal gas, the main equation for molecular kinetic theory, and then we learn thermodynamics laws. Have 3 laws of thermodynamics. First law, second law, and third law of thermodynamics. And then we learn what is entropy. This is for 5 lessons in total. And also during lessons we solve the problems. And questions and theoretical questions, like you had in our test. Okay, is there any questions until now? If you have something to ask, please ask. Okay. If no questions, then I'll start to explain all this stuff in more details. And today we solve some problems, basic problems. So we can solve tests from your previous exam today. So during the lesson you can send me, if you have some tests from the exam, you can send me them and I'll solve them, or I will show you my problems similar to the exam tests, and we will solve that problems. Okay, then okay, let's talk about physics. What is physics? Physics is the subject about the nature, natural phenomena. And physics deals with natural phenomena in quantitative way. Quantitative means, so we have physical quantities. For example, velocity, distance, time, mass, length, time, distance, force, acceleration. Then we have mechanical properties. These are mechanical properties, and thermodynamical properties like temperature, T, like heat, Q, or entropy, S, etc. All of these are physical quantities. So what is physics? Physics is a subject which learns nature, natural phenomena, the motion and the interaction in the nature by means of physical quantities. For example, when you learn the free-falling body, so you can say qualitatively, you can say, so heavier the body, faster it falls. But you can say the speed of falling doesn't depend on the mass of the body. So this is qualitative description. Qualitative. Sorry. Qualitative description. So we say higher, faster, slower, hotter, cooler. This is quality, but in physics still deals with not quality but the quantity. We don't say higher, faster, heavier. We say exactly the value. For example, mass is 10 kilograms, or velocity is 100 kilometers per hour. So in physics, we deal with quantities. We exactly say what is quantity. So how much is the value of the quantity? This is called the value of the quantity. This is the quantity itself. For example, mass has a value of 10 kilograms. Velocity has a value of 100 kilometers per hour. And in physics, we have two kinds of quantities. Quantities, we have two kinds. They are scalar quantities and vector quantities. Scalar quantities are quantities which have only the value only. And vector quantities, they have both the value and direction. So vectors, they have both the value and direction. For example, this quantity is mass, is scalar quantity. This is a scalar quantity. The scalar quantity, and this value is vector quantity. This quantity, velocity, is vector quantity. It has a direction. For example, we say 100 kilometers per hour. The speed of the car is 100 kilometers per hour and directed to the north or directed to the northeast, etc. So it has both direction and velocity. Okay? So these are difference between vectors and scalars. And about the vector quantities, we put the arrow. Arrow means it's vector quantity. In the books, if you see no arrow, then you see the boldface font. For example, velocity is boldface, V. If you see this velocity, boldface in the books, then you should understand that this is vector. And if you see the text, this kind of not bold text, this is scalar. So velocity, for example, can be both vector or scalar. So this velocity vector is called velocity and scalar is called speed. If you see the word speed, then you should understand that it has only the magnitude, no direction. But if you see the word velocity, then it's vector. So these are physical quantities. And in physics, you see the quantities everywhere. Mass, mass, speed, acceleration, force. So everything in physics is described by the physical quantity. And we have a lot of quantities, but main quantities are very few quantities. So not so many physical quantities. I'll tell you about the main physical quantities. They are in mechanics, there are three. So first we start with mechanics. That's why let's talk about mechanics. We have three quantities in mechanics, three main quantities. They are length, mass, and time. So I said that physics deals with the natural phenomena. What is nature? Everything what you see around is the nature. For example, you see the objects, bodies, solids, liquids, gas, plasma, etc. You know the four kinds of bodies. So we have Earth, planets. We have there are planets, stars, galaxies, etc. The universe, whole universe consists of stars, galaxies, planets, and in our planet we have different kind of substances like water, soil, etc. So everything is called matter. This is a matter, and every matter has a mass. This is matter, materia. So it has a mass, and in order to this matter to exist, we need the place where this matter is holds. So we need a space. So every matter is located in the space. We have three-dimensional space. Three-dimensional space is the place where all the matter is located, situated. And space, in order to measure the space, we need the quantity called length. So higher the length, the bigger the space. Or if you make length square, you get the surface area. So okay, if L is length, then L square is area. This is also space. Space in two dimensions, two-dimensional space. And if you make L cube, length cube, so weight, height, and the width gives you length cube. This is volume. Volume, and volume is space in three dimensions. Three-dimensional space. Okay, this is clear. And what is time? So we have a space, we have a matter inside the space, and then this matter is not stationary. So every day you see the sunrise, the motion of the earth around its axis. It gives you the change of daytime, daily change, rotation of the earth, rotation of the earth around the sun. This is yearly rotation of the earth around the sun. Or you can see the motion of the stars around the center of the galaxy. Of course, you cannot see, but astronomers can see via telescopes. So every matter inside the space is in motion. And how do we know the motion? How can we check the motion? What is motion? The motion is the change of the place of the bodies in space with respect to other bodies, with respect to other bodies. This is called motion with time. So imagine the motion. Imagine this is a rocket, and rocket moves up with some speed, and this rocket has it has a place here. After some time, its place in the space changes. This is a motion. And in order to measure the motion, we need the measure of the space, how the position of the body changes, and we have to measure the time. So because we measure the time, and this is also part of the space. And in modern physics, this is called space-time. And our physicists, they found that our space is not three-dimensional, but four-dimensional. Our space is four-dimensional space. So that means we live in four-dimensional space. Three are length, width, and height, and fourth is time. We have four-dimensional space. Okay, sorry. Think about that. We make a short break. Think about that. After short break, we will continue our lesson. We make a short break for 5-10 minutes, okay?